What is up, you guys? In this one, I'm going to walk you through the most important LaTeX commands so that you can render or prepare your scientific documentations. You could type in beautiful equations. Actually, any equation you see online, you can get it done with LaTeX. And I'm going to do so on my Notion notebook. You could be in class or you can be in a meeting and you want to take down some scientific notes or equations or whatever you're doing. And it's really easy to do that off Notion. So without further ado, let's get started. So let's start by basic math equations on LaTeX. How do we get this job done in Notion? Well, it's really easy. Just type in /LaTeX and let's choose block equations. Right here you can, just get started typing in any LaTeX code you want. So let's start with something really simple. First thing you want to do is do a begin equation and end equation as such, really easy. Then you can start typing in your equations. So you've got x equal to 1, or you can type in stuff like x squared equal to square root 3, stuff like that. So basic equations could be something like E equal mc squared, right? And as you can see, the equations are numbered for us. So if I go ahead, for example, and I do the same thing, let's say over here, and I type in, another equation. Let's say type in E equal to m. As you can see, the equations are numbered automatically for us, which is super useful. I could go ahead and say here, if I'm taking notes right here, I could say that, right here, what do you want to say? The mass energy equivalence is given by the following equation, right? Then if I want to refer to this equation, I could go ahead down here and say, well, equation 1 does, gives E as a function of M and C, right? Now, in case you don't want anything numbered, it suffices to, do an asterisk here and here. Then this equation will not be numbered. And this one will start from 1. Right? Let's say you want to type a very, you've got a basic equation and you want to type it really quick without the begin end equation. Well, off of Notion, you can use the inline equation, which is simply for, insert mathematical symbols in text. So I can do something as such, E equal mc squared. Really simple. Now next, let's say you want to use more advanced, other operations. Let's say, go back to LaTeX right here. Let's say you want to use square root. So you can do this via backslash, square root, and then enter your expression over here. So let's say x squared plus 3x plus 5, right? If you want things to be centered, we can go ahead and use this expression right here. So if I, do this and I copy paste this expression right here, there you have it. Okay, now let's say you want to do some integration. So let me go to Google, type in, famous integrals, and try to mimic what we have, right? So I'll go to the Wikipedia page, and right here we've got a list of integrals, as you can see. Let's say I want to type this in LaTeX, right? Let me just zoom in. I want this guy in LaTeX. Well, there's a trick for that. Off of Wikipedia, what you can do is, if you're lazy, you don't want to figure out the expression, you can go to edit and you will have the equivalent LaTeX code right here. Actually, this is not LaTeX, this is MathML, but MathML and LaTeX are really similar, right? So you can also use this. But let's say we're not going to use this because we found this equation on another website other than Wikipedia, right? So let's say I want this equation. Well, it will be something like, let's do the LaTeX first, and let's do the begin equation and the end equation first. Okay, so we go back here, we see that we have an integral. Well, an integral is defined as such, \int, right? Then you type your expression, which is a fraction, 1 over x. So you do frac, pass 2 arguments, 1 and x. This is your 1 over x. Then you've got the dx over here. You can either do dx like this, but I don't prefer it this way. What I usually do is a backslash so that we can have some spacing, as you can see right here. You can increase the spacing as much as you want. So 1 spacing is good. Is equal to ln absolute value of x. So you can do this. Be careful. This will leave an italic font, which is not what we want. We want it to be as such. So len is an operator recognized by LaTeX. You can do this. Got also other operators like log, like sine, like cosine, and so on. Let's do len. And it's not a len x, it's a len absolute x. So it's a vert and then another vert like this, plus a constant c. So this is an indefinite integral. Let's see if we've got some definite ones. So let me do this. As you can see, we've got a definite integral over here. So we can see that we've got the integration, but this time from 0 to infinity. So how do we do this on LaTeX? Well, let's get LaTeX, begin equation, and equation as such. Well, as we did previously, int, but this time we pass limits as such. So we go 0 underscore 0 means the lower bound. So as you can see over here, and now we pass it the upper bound, that is infinity. So we go and do this. Now if you do a number 5 like this, it passes, but if you do 55, the second digit will go within the integrand. So to force this, you enter curly brackets as such and pass it all the digits you want. So we need infinity, so we go backslash infinity as such, right? You can do this as well. And then you could, what do we have next? We've got the square root of x, exponential of minus x. So we go square root, as we learned, of x. Then we do e power minus x as such. And don't forget the dx. This is equal to half square root of pi. So we go frac, which is fraction, 1 over 2. Then we've got the square root of pi. So square root of backslash pi as such. Okay, I'll talk to you a bit in a while how to LaTeX all the Greek symbols. That is alpha, beta, gamma, sigma, theta, xi, and all these Greek alphabets. So yeah, this is how you get definite integrals done, right? Let's pick another I don't know, which one do you fancy? Let's do something like this, right? This looks really complicated, but really it's not. Let's do something like this. So we can see that the complicated part maybe is the curly brackets here for the cases, right? That's really simple. That's really simple. So let's start first by the left-hand side. We've got the integration from minus pi till pi, right? So let's start by begin equation and end equation. Let's do the integration with the limits from minus pi, right, till plus pi as such. Then what do we have next? We've got this cosine alpha x. So let's do cosine alpha x as such. Then we've got a sine, what was it? No, we've got a cosine power n beta x. So this guy is a cosine, and right here we've got a beta x, and the cosine is raised to power n, if I'm not mistaken. Right. Now equal to the right hand side. This is where it might get a bit complicated, but really it's not. So once you see this, remember the keyword cases, because you know when absolute value of alpha is absolute value of beta into 2m minus n, we've got this expression, otherwise we've got this. So the keyword here to remember is cases. So we do begin cases and end cases. As you can see, we've got this curly bracket open for us. So right here, I can start by the first line. So we've got this expression. Let's say this expression, just for the sake of simplicity, just to get the format properly rendered, is a. So this guy is a. I will replace it just in a few from now. And we go and then we go the condition, which is alpha is equal to beta into 2m minus n. For now, let's say this is condition 1, right? And then you do double backslash to go to a new line. And if I copy paste this guy, right here, I've got the second line as such. And you can repeat this. You can do, this is condition 2, this is B. You can copy paste this again right here. Got C for condition 3, but since we've got two conditions, I'm good with this. Now you can see that condition 2 is otherwise, so right here I'll type in otherwise. But in case you want it properly formatted, not in italic, you go ahead and pass the keyword text as such, okay? This guy is 0 otherwise, right? Else, it's 2 pi over 2n and choose m, right? So frac 2 pi over 2 power n, then you've got n choose m, so we'll do n choose M. But as you can see, n choose M is not properly rendered. We only want n choose M. So for the pass, curly brackets only for n choose M as such. Then we pass the condition. As you can see, it's alpha equal beta into 2m minus n. So we go alpha equal beta to 2m minus n. Then we've got the absolute values. So I'll do vert on the left, vert on the right, then right here, vert on the left, and then vert on the right as such. Okay, so this is really how you work your way around with LaTeX. Now here I know I've introduced you to many notations that I didn't, talk about here, like alpha, beta, the integration, the cases. But it's in LaTeX, it's really, it's like programming. You only learn once you start coding, right? LaTeX is pretty much the same. It's a scripting language. So you pretty much get your hands on this language through extensive exercise. Now, let's say you want a closed integral, right? So this part right here was all for integration. So I'll change the headline right here. I'll do heading, I don't know, 1, integration, definite and indefinite. Let's say you want closed integration. How do we do that? Well, it's really simple. Let's first go to Google and type in closed integral equations. Let's see if we've got something over here. Yes. Well, let's say I want to LaTeX, I don't know, this closed contour right here. The integration over C, 1 over Z is this expression. Well, this is really simple if you're on Stack Exchange. It suffices to click on the tech equation. You get the tech equation right here. And as you can see, this is an OINT. That stands for closed integration. Let's try to, do this without looking at the equation. Now, I know right here you see MathJax, but trust me, LaTeX and MathJax are really, really similar. Start seeing that you've got OINT, you've got the int from 0 to 2 pi and so on. So let's try to mimic this equation in our LaTeX. So we do LaTeX, right? Begin equation and end equation as such. Then we've got not an int but an OINT as such, right? To get this O looking thing right here. Then what I want to show you is first let's get this C right here. So this, I'm assuming it's an underscore C as such. Then we've got 1 over C dz. So frac 1 over Z, then a dz is equal to, and the rest we don't really care about because all I wanted to show you is how to get this O. But let's do the rest. So 0 to 2 pi, 1 over e to the power it. I is complex. So fraction 1 over e to the power it as such. And we've got an ieit. So I to the power eit. Then we've got a dt. This is equal to I 0 till 2 pi 1 dt. So I int limits 0 till 2 pi 1 dt, which is I, you know what, I'll just do 2 pi as such minus 0, which is 2 pi I, right? Now, in case you want something that, where the equals align, let's say you wanted to break the line, right? You can do this using, what I do is using the split. So right here you can pass begin split, right? And just before the end equation, you do an end split, okay? Right now, nothing happened because we didn't tell LaTeX where to split. Well, let's say you want to split, I don't know, on this equal right here. It suffices that you pass an and as such, and then you specify where you want to split. So let's say you want to split over here. You grab this guy, you pass the and right here. But as you can see, there's an error. You have to pass 2 backslashes as such. Okay, let's say you want to do this as well over here. So you go to this right here, pass the and the double backslash as such. You've got this equation. Okay, let's say you want to do some, I don't know, summations, right? And here I'm getting a message from David saying, hi Ahmad, Notion has updated its privacy policy. Okay, okay. So let's say I want to do some summations. I'll go here, type in famous summations just to get an example, right? Got all those summations. Let's say I want to do, do the full Haber's formula, right? Let's do this. So Haber's formula, and I'll insert some LaTeX code. Begin equation and equation. So you need a sum instead of an int. Now we're using a sum, and we need limits. So k equals 0. K is running from 0 till m. So we pass limits underscore k equals 0 till m. Then we've got the expression k to the power n minus 1. So we do k to the power n minus 1. This is equal to this fraction. So we've got the fraction over n, right? And then we've got bn of m plus 1. So bn of m plus 1 minus bn. Okay, simple as that. That was easy, right? All we did was instead of the int, replace it by the keyword sum. Let's say you want famous products. You've got this right here. Say you want an pi I going from 1 till 6. So products, again, begin equation and end equation. So right here you do a pi as such. I don't think it's a pi, I'm sorry. I don't think it's this. I think it's a prod. Well, in case of doubt, type edit and let's see what they've got right here. So we've got a prod, exactly. Why didn't I? P should be lowercase. So there you go. This is the prod for product. Then, if the limits here are not that good, if I do this, I equal 1 till 6. Oh, I've got it properly rendered. Because I've seen other, I think Notion is good at, rendering proper LaTeX. If you're using other type of softwares to do that, for example, on Overleaf or some other, tech software, you should pass limits to properly render. Otherwise, it will appear as such. Okay. Now we've got I square, so you can pass I square right here. And this guy is equal to 1 times 2 squared times 3 square times 4 square times 5 square times 6 square. And just to be consistent, I'll do a 1 square. Okay, so this is how you work yourself with operations on LaTeX. We've done products, summations, integration. Let's do some relational operators. So let's say I want to mimic this equation I see over here. We know that we're going to use cases, right? So let's do this. So right here, LaTeX, begin equation and end equation. So right here, E is equal to begin cases and end cases. We've got 4 cases, right? So case 1, and do this. Now since we're not specifying a condition, I'm not going to be using the and symbol. So I'll just copy paste this guy 3 more times. 2, 3, and 4. Okay. Right here I've got x is less than y, and then right here I've got y is greater than x. So let's do this. It's very simple. X less than y, and y is greater than x. We also got x is not greater than or equal to y. In case you want a greater than or equal, you do GEQ, which is greater than or equal y. But we want a not greater than or equal, so I'll pass n, which stands for not greater than or equal. Okay. Likewise, I can do it less than or equal, such. But since we're interested in not, so I'll do this. And here I have to flip y with x. Okay? All those are equivalent. Talking about equivalence, we could remember the notion of implies, A implies B, B implies A, and so on. So, if I want to include some arrows in my LaTeX, suffices, let's start with begin equation and end equation first, to remember the keywords arrow, left arrow, right arrow, as such. So, first L brace and R brace, those are braces. You can't do this because this is not recognized. This is just to, include one expression as is. L brace and R brace, let's say I want L brace and R brace. Let's say I want x less than y implies I can do this. Then let me copy paste this guy and replace and do y greater than x, right? Can do this. You can also do it the right arrow way with R being uppercase, because if it were lowercase, you won't have this double, arrow right here, right? So uppercase R. But since this guy is also valid for the other way around, so left arrow, right? Then we can have an equivalence relation. That is a double arrow. You can also have double arrow as by using, I think it's left right arrow as such. If it's not left right, then it should be right left. Let me try this. Where L is lowercase. No, it's not. Maybe R should be lowercase. Let me repeat this. Left, right arrow. Oh, there you go. So left, right arrow. If L were lowercase, you would not get this double arrow. Okay? Okay, good. We've seen some basic operators on LaTeX. Let's check how to, work with brackets and parentheses. So since I'm going to input only pure equations, I'm just going to use the equation mode. So right here, I don't need to enter begin equation and end equation. Let's say you want some simple parentheses, so round brackets. You can do this, right? Now, let's say you want brackets, so square brackets. All you have to do is enter the square brackets as such, okay? Now, let's say you would like curly brackets. Again, those do not work, okay? So those are do not work. It's just to, include an expression. You can either do this, so left brace and right brace as such, or if you want things faster, you do backslash, then left brace, and backslash, right brace. Let's say you want angle brackets. It's really easy. All we need to do is say left angle and right angle and pass our expression as such. Now let's say you want to use pipes, vertical pipes. So you can do this, right? And say x plus y, but some softwares don't take this special character. So you'd have to do something like vert, right? Okay. So vert, okay. And let's say you want double pipes. So something like Frobenius norms or Euclidean norms or stuff like that. Well, you could find something like this, but it's not the most elegant way, right? What I like is vert with V uppercase. This is more elegant, okay? Or you could do something like backslash and pass it the pipe character. This all depends on the software you're using to render your LaTeX. Just giving you different options. So now you can use all those to have a composite expression, something like, I don't know. And another thing about this different options is that you can also pass the word big. If you want something to be big, you have to say you've got big as such. You've got double G. Triple G doesn't work, so you go ahead and do B, uppercase B. And if you want it even bigger, you do uppercase B and G as such. There's no triple G again, okay? So why am I saying this? Well, let's say you want a composite expression. This time, let me do it off of the block equation. So right here, I'll do begin equation and end equation. Let's say you've got something like, I don't know, a fraction that is n over, you've got another fraction in the denominator that is L over M. And then you've got a minus K plus N as such. Now, as you can see right here, what do we have here? We've got those brackets, but they're really small, right? So let's say you want to enlarge them. We can do it as we just said right now. So let's say we do big as such. Big is still small, so I'll do a double G, perfect. Then I'll do the same thing right here, okay? And voila, this is how you do it. Now, let's say you want to work with subscripts and superscripts. We've already seen this up here. Where was it? So exponential to the power minus x, this is a superscript. But let's say you want to work with subscripts. So superscripts. Well, it's really easy. Y underscore means sub. So Y underscore I, Y of I, and chapeau is super, okay? Let's say you want bi indices, two indices. You can do curly brackets, then ij as such. You want a comma, you can insert a comma over there. Then you do y, I don't know, ji is, I don't know, x to the power 3k plus square root of y, okay? So really, this is some basic LaTeX that could get you started exploring LaTeX, taking notes on Notion, using LaTeX. And really, this is super, super useful for your research, for your classes. If you're in a class, you want to, highlight important notes your professor is saying during class. This is one, I find, excellent way of doing this. Now, of course, this requires you to be fluent in LaTeX. I agree. What I would do first is take notes on a paper and pencil or using an Android tablet or something like that. And then, at home when I want to, practice my LaTeX skills, I'll just, punch this in Notion. So this is really how I also work my stuff around when I want to take notes while reading research papers and stuff like that. I find this to be an excellent way. Now, in case you want more LaTeX courses, let me know. I'm a very fluent LaTeX person. Actually, I use LaTeX to write papers, and so yeah, thanks for watching. If you found this tutorial beneficial, please leave a like on the video, subscribe to the channel. If you have any questions whatsoever, kindly leave a comment down in the comment section below. I'll make sure I'll get to it as soon as possible. I'll see you then.